Hi everyone, welcome back. In this video, we will see one of the CPU scheduling algorithm called first come first serve CPU scheduling algorithm. Shortly we call it as FCFS algorithm. Guys, this algorithm works like the process that requests the CPU first is allocated the CPU first, which means first come first serve. I mean, if I say process P1 is requesting for the CPU, process P2 is requesting for the CPU, process P3 is requesting for the CPU, at the time it's like 4 nanoseconds, 9 nanoseconds and 2 nanoseconds. Which one will get the first chance? First chance will get for the P3. It is because of first requested the CPU by P3. Next requested the CPU by P1. Next requested the CPU by P2. So based on the first come first serve, they will serve the request. So which I can say that they will serve the request in the order of FIFO order, first in, first out order. Right? In other words, if I say this is a kind of a queue, something like this. The processes will enter like this. P1, like as per this example, if I resemble P3, then P1, then P2. P3 completes task, then P1 completes task, then P2 completes task, and so on. Right? So let me explain this particular algorithm with an example so that we will get clear idea. For example, the data set as follows: process ID, arrival time and bus time they have given. Process ID can be taken as string also: P1, P2, P3, P4, P5 and P6. This is the data set they have given with process ID. Arrival time means the time at which it has entered into the ready state. Bus time means the time for which it requests for the CPU. For example, if I say P1 is the process ID for process 1 whose arrival at 0 and it requires the CPU for 4 units of time. Okay, then finally you have to calculate various kind of things. One is starting time of the process, another one is completion time of the process, and turnaround time of the process, and waiting time of the process. You have to calculate these 4 factors. Guys, they may ask anything in the examination, so we are going to solve all the questions what are possible in this particular algorithm with a single table. Okay, now we'll try to solve this particular data set for the algorithm first come first serve with respect to Gantt chart, right? So the advantage of Gantt chart is we can able to represent how the processes are executing in the CPU. We can define with respect to the Gantt chart, right? So initially CPU starts with 0 nanoseconds. You have to think that at the time of 0 nanoseconds, what are the processes are readily available in the ready state? That will be only P1, because P2 is available at 2 nanoseconds, but we are at 0 nanoseconds, so P1 is only available. So P1 is going to enter into the CPU and will execute it for how many nanoseconds? Burst time, that is 4 nanoseconds it is going to execute it. Means it will be completed by what time? 4 nanoseconds. So it will be completed by 4 nanoseconds. And it was started at what time? 0, right? This represents starting time of process P1 and this represents completion time of process P1, right? by the time of completion of 4 nanoseconds, what are the process available for us? P2 is available and P3 available, because P2 having arrival time is 2, P4 is arrival time 4, so which are less than this. So P2 and P3 are available for execution. Now CPU scheduling algorithm we are following, that is FCFS algorithm. Am I right? FCFS means the criteria here. Criteria is what? Non-preemptive mode. Non-preemptive mode. And the criteria will be here we are using FCFS algorithm and non-preemptive mode we are using, and the criteria will be, means on what factor we have to work, means on the arrival times, right? Yes. So when the time is 4, P2 and P3 are available. Now out of these two processes, which one you have to enter into the CPU based on the algorithm, FCFS algorithm, right? First come first. So first P2 is come, so P2 will get the chance and will complete until the completion time, because it is non-preemptive mode. So it will complete for 2 nanoseconds, it will complete by 6, which means process P2 starts execution by 4 and completed by 4 nanoseconds, which means 6 nanoseconds. Now by the time of 6 nanoseconds, what are the processors available now? P4 also available, means P3 and P4 are available. Now which one will get the chance? P3. P3 will execute for 5 nanoseconds and will complete by 11, which means starting time of the P3 is 6 and ending time of the P3 will be 11. By the time of 11 nanoseconds, all the processors are available to execute, but which will give serve to what? The first come first serve base, right? So you will get P4 executed for 6 nanoseconds, that will be 17, means P4 entered at the 11 and exited the 17. Next one P5, which will burst time will be 3, so it will be 20, means 17 is starting time and completion time is 20. Similarly P6 starting time is 20, ending time will be 21, because burst time is 1. Burst time is 1, right? So hope you understood now how we are writing this Gantt chart, right? Once we have written this particular thing, starting time and completion time, can we define the turnaround time? Yes. What is turnaround time? Difference between completion time minus arrival time. What is completion time? 4. Arrival time is 0. 4 minus 0 is 4. Similarly 6 minus 2 of process P2, 4. 11 minus 4 for process P3, that is 7, and 17 minus 5, 12, 20 minus 8, 12, 21 minus 10, 11. These are the turnaround times of various processes. Coming to waiting time, we can say it as difference between turnaround time minus burst time. Turnaround time minus burst time, right? What is turnaround time? 4. Burst time is 0, means there is no waiting time, as it comes directly and it will execute it. And turnaround time here is 4, it will be 2, which means 4 minus 2 is 2. If you observe clearly, process P2 arrived at 2, but it has not get a chance, because P1 is already executing. But after completion of 2 nanoseconds, means by the time of 4, P2 got the chance. So it is waiting time is these 2 nanoseconds. That is what I have written here. Next 7 minus 5, 2 nanoseconds has waited, and 12 minus 6, 6, 12 minus 3, 9, 11 minus 1, 10 nanoseconds. So these are the various waiting times for the various processes, right? Now calculate what is the average waiting time of average waiting time of all process and average turnaround time of all process. So average turnaround time means, which I can say, turnaround time of process P1 4 plus 4 plus 7 plus 12 plus 12 plus 11 by total number of processes 6, right? I have taken these all the things by 6, which is approximately 8 7 15 15 plus 24 39 50 by 6, around 8.2 nanoseconds, or we haven't included whether it is a nanosecond or second. We'll simply take it as 8.2 units. Similarly, so 8.2 units is the average turnaround time. What about the average waiting time? Average waiting time will be 0 plus 2 plus 2 6 plus 9 plus 10 by 6, 10 19 29, so 29 by 6, which is approximately 5 minutes. Am I right? 6 5 30, 1 unit less, it will be like 5 minutes. So average turnaround time, average waiting time will be 5 minutes. Hope you understood now what is the exact meaning of turnaround time and the exact meaning of completion time. And we have seen the schedule length. We need to calculate schedule length. Schedule length means what? The maximum time taken for to complete a particular process. Maximum completion time of particular process minus minimum of arrival time of a particular process. What is the maximum completion of a particular process? Observe, maximum time of all the processes will be 21 minus minimum arrival times of all process. Minimum arrival time of all process will be 0, which will be 21. And next thing we can calculate the throughput. What is throughput? We can say throughput means, if I say for n process it will take L schedule length, for one schedule length how it will be, right? So if you have gone through the video of various scheduling technical terminologies, you can understand this one, which means I can say it as n by L, which means 6 by 21, which I can say it as 0.28 processes completed per unit of time. Per unit of time we can complete. Okay, what is the efficiency then? What is a CPU efficiency? How much time CPU utilized by you? That is 21. Out of that, is there any time you have wasted to make the CPU idle? No. That is 21 times you have utilized perfectly. So 21 by 21, which will be utilized 100% effective utilization. Is there any wastage of CPU utilization? No, 0%. CPU inefficiency is 0%. CPU efficiency is 100%. CPU inefficiency is 0%. Like that, the first come first serve algorithm is going to work. Hope you understood this particular concept along with the example clearly. Thank you.